Hello, I'm Kevin, and today we're going to work on some calculus problems using Epiphany. There are other videos that show you how to get started with Epiphany and how to handle some of the basic capabilities and tutorials. Check our YouTube channel or the tutorials page in the Epiphany website for those. Let's go ahead and jump on in. I'm going to start by sharing my screen. There we are. Move this up here. I've already gone ahead and created some example problems that have different types of calculus that we're going to do and show how we can do those with Epiphany. Later on, I'll show you how you can enter those. However, if you have a little bit of advance notice, we're happy to enter these problems for you, either as a teacher or as a student. Just send an email with the problems to support@epiphany.com, and we'll get those in for you within 24 hours. And if you get it to us early in the afternoon, right after school, we try to get those done as quickly as we can, but we can't promise that we'll be done by 6 if you get it to us by 3 o'clock. Okay, let's start with this problem on limits. So you'll notice first that we've set a variable equal to this limit. Right now, all problems in Epiphany must be equations. So we're going to set this variable y equal to the limit we're trying to take. We're going to start out like that. Now, I could enter y equals, and I could write out a limit. There's a way to type this using math language. It's a language called LaTeX that we use. You can enter anything with LaTeX. Instead of doing that, I would recommend, especially for limits, using these calculus functions here. We can enter a limit just like this and adjust it. Or better yet, you can copy and paste this whole line with this copy button here, or with Control C, Control V, Apple C, Apple V. This button will paste it on this line, and we can start adjusting it. By the way, the first thing you should do on this limit is plug in 3. You'll find very quickly you get 0 over 0. If you put in 0 over 0 in Epiphany, it's going to say, hey, I don't understand that. It's infinity. It's not going to work. That's the whole point of why we have to put in a limit here. So let's start off by factoring the numerator, and we're going to get x minus 2 times x minus 3. And I can either hit enter or press this next step button to take the next step. It's happy with that. Let's copy and paste again. And actually, before I do that, a lot of people at this point would simplify this and say, oh, this is just y equals x minus 2. That's actually a mistake. Most calculus teachers get really picky about when you get rid of the limit. You can't get rid of the limit yet. You need to reduce it and then get rid of the limit. If I enter this here, I'm actually going to get an error. It's something we're working on, a little glitch related to how we look at things. Occasionally this will happen. You can enter anything. There will be some time that we get confused by it. If that's the case, try entering it a different way. Or maybe you made a mistake along the way. That is usually what happens when a message like this comes up. Because we can handle anything, we get a whole bunch of different possible issues that we have to be able to address, and we're always working on improving that. So let's clear this out and change this over. And I'm just going to delete it. And this, it deletes properly just right across the fraction. You can also select that way as well. It's the limit as x approaches 3 of x minus 2. And now we can plug in x equals 3. When I do that, I get y equals, and I'm going to be a little bit more deliberate than usual here, y equals 3 minus 2. That is the proper next step. And we can now say y equals 1, and I can now click done to say that I am finished with this problem. I can then move on to the next problem. I can also add comments in different places if I want to, or scratch work, other types of things. That's all possible. Let's put this next one in. Okay, so for this next problem, we have a product rule differentiation problem. And you'll notice that we have a variable y, once again, equals d dx. That's the one form of writing a derivative. We don't currently support y prime, but it's something we're planning on adding soon. For this derivative, we need to use this is the Leibniz notation, d dx of this function. You're going to have to use that along the way if you want to do partial steps. One thing a lot of students get wrong with these product rule problems is they'll take the derivative of both parts. Hey, y equals 5x to the 4th times cosine of x. Well, not quite. That's not how you have to do this problem. We got some advice here. How would you implement this with product rule? We're going to cancel this and not answer those questions right now. We look at your feedback and look at how you're doing it. I know what I had to do. I had to say y equals 5x to the 4th times, and I'm just going to take this in small steps. Cosine of x prime. Oh, I can't say prime. I have to say d dx of cosine of x plus x to the fifth. No, that was wrong. I meant to say it this way. Hang on a second. Equals x to the fifth times derivative of cosine of x plus the derivative of x to the fifth times cosine of x. I take 1 times the derivative of the second plus the second times the derivative of the first. I'm going to click next step here, and it likes that. That's because I entered the wrong equation. A lot of mistakes, in fact, 90% of the mistakes people make in calculus problems are silly little mistakes. Things like exponent errors, trigonometry errors, stuff like 2 times 4 is 18. Everybody does it. Just watch for it. I've made that correction here, and there we go. Okay, let's go ahead and simplify each of those pieces now. The derivative of sine of x we know is cosine of x. Derivative of x to the fifth is 5x to the fourth. And we've got it. That's it. Notice that, hey, you can simplify this, but we're good with that. Most calculus teachers don't want you to try to simplify this by factoring out x to the fourth. That's not necessary. Let's go on to another problem. This one involves the chain rule. We're going to do the same thing here. So how do we take the derivative of this using the chain rule? Well, remember, we're going to set u equal to the thing on the inside to make this easy. Let's go ahead and do that. U equals negative 3x to the fifth plus 1. I want to make a note of this, but it's really not part of solving the equation. It's kind of my scratch word. So I'm just going to say entry without review. And it's just going to make a note of that. That'll show up in the steps for this problem. I can now say y equals 3 negative 3x to the fifth plus 1 squared times the derivative of negative 3x to the fifth plus 1. We can't actually use u there yet. It's something we're planning for the future, but for now, you can put that piece in here. What we're doing here is just saying, hey, it's 3 times, it's the derivative of u cubed, which is 3u squared, times the derivative of u. Let's take the next step on this one. And we can now finish this up. I'm going to copy and paste. Derivative of negative 3x to the fifth. You'll notice I'm using parentheses liberally. Without parentheses, a lot of times, Epiphany will get confused. In fact, a lot of times it's actually wrong if you don't put parentheses in there. This is going to be negative 15x to the fourth. And with Epiphany, you could click done like this, or we can actually go ahead and simplify this a little bit. I'm going to move this part up front because I like organizing it in a particular way. And I'm going to merge the 3 and the 15 and make that negative 45x to the fourth. And here we go. We got the final answer for this problem. So similar situation for integrals. We set a variable equal to an integral we're going to take. And I'm going to start out by changing this into exponent form, converting quickly and easily between radical and exponent form for these radicals is very useful when taking integrals. And now I can just take the integral y equals 1/6 3x to the sixth plus 1 over 3 halves. Let's just put it in that way. 1 over 3 halves x to the 3 halves plus a constant. We don't have all of our advice quite ready yet. It should make a note if you don't put a plus c in there. It doesn't yet, but watch for that coming up soon. Next step here. And copy and paste. We'll change this to 2/3. And this becomes 1/2. And we've got it. So that shows how you can do a variety of different types of problems using Epiphany. When we're done with this, we can now go back to our assignment and we can print this out for turning in. It's got information, so how your teacher can actually link to this and see what mistakes you made. That's a good thing. Teachers want to be able to see where you're making mistakes so that you can improve, and so they know what they need to teach in the upcoming lessons. And it has examples of what went wrong and what you did right. And then also some more about Epiphany and some notes about, hey, it's not doing it for you. You're doing this yourself, and how this can be helpful to teachers, some information for the teachers if they want it. So you can just print this out and turn it in if you want to. Thank you for checking out this how to use Epiphany with calculus problems. If you have any questions, please contact us at support@epiphany.com.